Dear Heavenly Father, we thank you for this day again. I thank you for this class and for the students. Just ask you to help us to use this time wisely, just to glorify what we do, and just to resolve any remaining questions there might be about this material, Lord. In your name I pray, Lord Jesus. Amen. So I have a few examples to show you guys. Let me get to them. Let's see here. Let's see here. Let's try our hand at example 1. Suppose you want to solve this character right here. Number 79 of section 4.5. Check this out. Natural log of e to the x minus 2 times the natural log of e is equal to the natural log of e to the power 4. Now, at first glance, this looks like a possibly difficult problem, but if you know what's going on, if you know what time it is, so to speak, this is a very simple problem. Because what is the natural log of e to the x? X. Right. And what is the natural log of e? Well, you guys have calculators. If you don't know already, try it out. Plug it in. See what you get. Natural log of e, we get 1. So that's minus 2. What's the natural log of e to the 4? 4. It's just 4. So this is x equals 2? 6. So, yeah. Let's look at number 81. From section 4.5. Here we have log base 2 of log base 2 of x equal to 1. And we're supposed to solve this thing. All right? Now, I don't guess we've done one quite like this up to this point, right? But we can solve this. How should we do it? How do you obliterate log base 2? What do? You just take both sides and exponentiate base 2, right? So I do 2 to this is equal to 2 to the 1. Now 2 to the 1 is just 2, right? So what this gives me then is log base 2 of x is equal to 2. Right? Exponentiating both sides base 2. Then what do? Anybody? See, I think I should start calculus because you guys are bored with this material. I should start something new, something fresh. You're not bored. You just don't understand.
I'm not bored. I'm just trying to figure it out.
Oh, okay. All right, fine. I will not interpret your silence as boredom. Rats. So then what do you think we should do? You got any ideas, Robert? Anybody else? Yeah. Right, yeah, just take exponentiate at base 2 again, right? So then 2 to the log base 2 is 2 to the 2. Now this gives us an x, and 2 to the 2 is 2 squared, which is 4. So x equals to 4 is the answer. That wasn't bad, was it? Not too bad. Ooh, I don't know about this number 82. Let's try this one. This one looks fun. Can we solve this, example 3? Let's try this one out. Try this on for size here. We're supposed to solve log of x equals to the square root of the log of x. Goodness, how am I going to solve that? Square both sides. Okay, let's do that. So then we get log of x squared is equal to log of x, right? That's a good idea. And that almost looks like something I know how to solve, right? What would I need to, maybe if I change the letter. Maybe if I change the letter. If I just make a substitution here, maybe you guys can see how to do it, right? What if I let y equal to log of x? Then what do I have? Then we're trying to solve y squared is equal to y, right? And all of a sudden, then that, I think I know what to do with that, right? Bring everything to one side. That gives me y squared minus y equals to 0, which gives me y times y minus 1 equals to 0, right? Y. Sorry. I'll let you guys say that. I don't need to say it as well. Anyway, so that gives us what? Y equals to, apparently, either what? Either we get y equals to 0 or y equals to 1. Now, we're not trying to solve for y, right? We're trying to solve for x. So what are we up against here? We either got ourselves a log of x equals to 0 or log of x is equal to 1. By the way, it would be good for you to know that the log is a one-to-one function and that there are some values of it we should just know, all right? So like, for instance, like log of 1 is 0, log of 10 is 1. These are a couple of like basic identities that we have for the logarithm. Like in this previous problem, the natural log of e was 1 because natural log is really log base e. So like log base e of e is 1. This is actually log base 10 of 10, that's 1, right? Generally speaking, log base a of a is 1. So if you know what I just boxed in green, you can just tell me what the solutions are. What are they? X equals to, for the left one, x equals to 1. And for the right one, x equal to 10. All right? Now, if you don't see that, suppose you don't see that, how can you solve the red equations at the bottom? What's the other way we could do it? How do we get rid of log base 10? We just exponentiate the equation base 10, right? So the other way you could think about this would just be, oh, I'm going to 10 to this is 10 to that, and 10 to this is 10 to that, which gives me x is equal to 10 to the 0, also known as 1, or x is equal to 10 to the 1, also known as 10, which of course gets us to the solution of 1 and 10, just like I talked about. Now, after all of this is done, the question is it correct? See, because we made a step, like Robert made me square the equation, remember that? And sometimes when we square equations, we adjoin extraneous solutions. Did that happen here? Try it out. Try go back to the start, put in 1. Does it work? Is log of 1 equal to the square root of the log of 1? Well, the log of 1 is 0. Is 0 equal to the square root of 0? Sure, fine, no problem. How about 10? We plug in 10 to the original equation. We got log of 10, which is 1. And then the square root of 1, which is 1. 1 equals square root of 1, yay. They both work. They're both solutions. Got it. Let's see here. We could do some of these earlier. We've done problems like the earlier ones here. I can do another one just for the sake of, you know, for fun. Let's try 67. Can I erase here? You guys good? Or do you want me to? Tell you what, let me put this silly thing away so I can work on the middle board. So example 4. Example 4, I've got log base 2 of x squared minus 100, I think it is, minus log base 2 of x plus 10 is equal to 1. We're supposed to solve this thing. Can we do it? What do you guys think? Let's use the properties of the log, right? Well, how can we simplify the left-hand side? We've got log base 2 of what? So we divide, right? Properties of log, we have subtraction, so we get division of the arguments in the log. So we have x squared minus 100 divided by x plus 10 is equal to 1. Which then, if I exponentiate base 2, right, what do we get? So we get 2 to the log base 2 equals 2 to the 1, which gives me x squared minus 100 divided by x plus 10 is equal to 2. I think we could have done something a while ago. We probably should do it at some point. Let's factor that x squared minus 100. What is it? Yeah, x plus 10 times x minus 10, right? Oh yeah, then we can exactly just cancel these. We get x minus 10 equals to 2, x equals 2, 12, right? And canceling them, we're not missing anything that matters either. If you think about it logically, we've got a log base 2 of x plus 10, right? When is canceling x plus 10 not allowed? It's when x plus 10 is 0, right? But hey, when x plus 10 is 0, the original equation is not defined either. So we're not missing anything by doing that. So x equals to 12 is allegedly the solution. Now we should check, right? What happens when you put 12 back up into here? You got 12 squared, which is 144. 144 minus 100 is 44. Log base 2 of 44, we can do that. And 12 plus 10 is 22. We can do that. So, yeah, it's good. Do you want to work out why it works? Yeah.
I just don't get why are we dividing into the same why are we writing the first log?
Oh, this is a property of logs. So, you know, like log base 2 of A minus log base 2 of B is log base 2 of A over B. It's a property of the logarithm. And the reason I'm doing that is so that I just have one log rather than two. If you want, we could hit the original equation with the exponential base 2 and see what happens. We'd get to the same thing. Hey, let's check our answer. Let's see how this works. So, how does it work? That's probably a good calculation for us to try out here. So let's look at log base 2 of, you guys tell me, what's 12 times 12 is 144. 144 minus 100, right? Minus the log base 2 of 12 plus 10, right? All right, so what is that? We've got log base 2 of 44 minus log base 2 of 22. Oh, so then by the properties of logs, that's what? That's log base 2 of what? Log base 2, 44 divided by 22, which is log base 2 of 2, which is 1. So, hooray! It works. Now, you don't actually have to check your, I don't usually check my answer altogether like that. It's not bad to do it, But what I always try to do is to make sure that the logs of the original equation at least make sense. All right, let me show you one where that doesn't happen. It's helpful for us to look at this example where it didn't go well. So like log of 7 minus x, natural log of 1 minus x, 7 minus x, 1 minus x, 25 minus x. 7 minus x, 1 minus x, 25 minus x. All right. So the natural log of this, I got to check it. I'm not sure if it was plus or if it was minus there. Just a second. I'm copying a problem from section 4.5 right now. This was section 4.5, number 63. Yeah, it's a plus. All right. So this one here, example 5 for us. So this time, notice that we've got a plus instead of a minus, right? So instead of dividing, we multiply. Like we've got natural log of 7 minus x times 1 minus x is the natural log of 25 minus x. Now natural log is log base e. So the right move here is to exponentiate, exponentiate both sides. So I do, and of course, you could just use the one-to-one property and go straight to the step I'm about to write down, which is that 7 minus x times 1 minus x is equal to 25 minus x. You should be very proud of me. Up to this point, I have stopped myself from making any kind of Taylor Swift joke so far. Lots of x's here. It's very hard to restrain myself, but I'll manage. So x squared, like it gets funnier every class that you say it. Like the 10th time is the funniest time, really. Let's see here. So plus 7 is equal to 25 minus x. So I multiplied it out. Yeah. And now I want to group everything on one side because it's a quadratic equation. Maybe we can factor it, right? That would be nice. What you got? You got x squared minus, minus 7x. What's 7 minus 25? Negative 18, correct. So what do you guys think? Can you factor that? Well, 18, it's 1 times 18, it's 2 times 9, it's 3 times 6. Ooh, 2 and 9, the difference of 2 and 9 is 7. I bet it's a 2 and a 9. Let's see here, so x, which one wants to win? The 9 wants to win, right? So x minus 9 times x plus 2, I think that ought to do it for us. Because that multiplies to give me a minus 19 and a minus 9 plus a 2, which is a minus 7. So yeah, factored. Now what? Solve gives us what? So we either get x equals to 9 or x equals to minus 2. But then we need to check it, right? Check them. With original equation. The original equation, we've got natural log, so let's try x equals to minus 2, for example. X equal to minus 2, we got natural log of 7 minus, goodness gracious, 7 minus a minus 2 plus the natural log of 1, 1 minus a minus 2 equals the natural log of 25 minus a minus 2. I think we're good. Everything's positive. We should be fine, right? You got what? Like you got natural log of 9 plus the natural log of 3 is equal to the natural log of 27. All right, it's fine, it works just fine. So this time the negative one is included, it's not extraneous, but what happens with the positive solutions here? Bad things, right? The bad thing. X equals to 9, oh, I've got natural log of 7 minus 9, which is the natural log of minus 2. This does not exist. We can stop right there. All you got to find is one piece of the original equation which is undefined, and you're done. It doesn't matter if everything else is hunky-dory. The one thing that's broken is enough. All right? So, yeah. So that makes this one extraneous. And the answer here is simply x equals to minus 2. So guys, any questions about anything? You guys are just waiting for the break? Yeah.
But how did the 8 turn to a 7?
We had the X.
Oh. How the,
Ah, okay. That makes sense.
oh, this here?
I had not-
Oh, yeah. Added x to both sides. Perfectly legitimate question. Other questions?
Now this is going to be a real super question because I probably was supposed to know this a few weeks ago. How are you doing the natural? How are you finding the natural log just like that? I never understood how you do that.
Oh, that's simple. That's simple. What is the natural log? The natural log is the inverse function for the exponential, right? So remember, the exponential looks like this, right? You got the line y equals x, and the inverse function to the exponential is reflected across the line y equals to x. The domain for the inverse function is the range of the function and vice versa. So because the range of the exponential is 0 to infinity, the domain of the inverse function, well, the domain of the natural log is the range of the exponential, and that is 0 to infinity. So that's how I knew that this is nonsense. See, because I know that we can only input positive numbers into the natural log. The domain of the logarithm, and it doesn't matter if it's base e or if it's base 10 or if it's base 2, all the bases, you must input positive numbers because the domain for the log is the range for the exponential, and the range for the exponential is 0 to infinity. That make sense? Mm-hmm. Okay. So that's how I knew. Once I hit minus 2, game over, no can do. Unless we can talk about complex exponentials. But that has been forbidden me. Yes? What? What's that?
How did you get to the natural log of last
7 minus 9? Because
That's not the one that works out, that's just one of the...
this piece right here, this is the weakest link. I mean, you could do natural log of 1 minus 7 also. Also bad, right? Again, does not exist because it's log of negative number, which is no allowed. In this class, at least. In my other class, it's allowed. In fact, I put it on the test. They signed up for it. They're math majors. It's fine. Now, the log of 0, that's never anything. Log of 0 just continues to be undefined. But log of negative numbers we can actually define. They just take imaginary values. Anyway, other questions? Let's look at an inverse function problem. So this problem I'm about to show you is kind of like problem 75 on your mission. So I think it's helpful to you for me to do it. Like I said, this is kind of sort of like problem 75 on the mission. But I did it for the other section, so I'm going to do it for you guys because I think this is a nice example. Now, the example, what it starts with here is not actually, I mean, the start is actually, I'm answering the question in the mission, but the part at the end, I think, is pretty. Example 6. So here's the question. Let f of x equal to the square root of, I don't know, x minus 16. No, I'll do 9. I'll do 9 again. Why not? I'll be boring. It's the same thing I did in the other section. X minus 9. Then the question is, show f1 to 1 two ways. Let's show it algebraically, and let's also show it graphically, okay? Let's look at both. Now, I think in your homework, I just give you the option. You can pick one or the other, all right? But let's talk about both because they're both easy. So algebraically, how do you do it? So to show a function is one-to-one algebraically, you begin by assuming f of a is equal to f of b. But what does that mean here? Well, here, that means that you have the square root of a minus 9 is equal to the square root of b minus 9. Then what? How do we, I heard a square? All right, I like it. Square it. So square root of a minus 9 squared is equal to the square root of b minus 9 squared, which gives us what? That gives us a minus 9 equals to b minus 9, which of course then gives me a equals to b. Hooray, we're done. Thus, f is 1, 2, 1. So this is the algebraic test. We set f of a equals to f of b. We do algebra. If we can show that a equals to b is the natural consequence of that, and that alone, then we're good. Now if we get a equals plus or minus b, it's not 1 to 1. Yeah. Oh, okay, yeah, like, for instance, counterexample, if we had like f of x equal, the usual one, x squared, you know, then you'd have, you know, f of a equals to a, f of b, which would give you a squared equals to b squared, which then tells you a is equal to plus or minus b. Oh, not 1 to 1. You know, different case. There's an example of not 1 to 1. If you just had f of x equals to x squared, when we set a squared equal to b squared, that allows us to find the solution a is plus or minus b, which is not 1 to 1. Now that's graphically even easier to see. So what does the graph look like here? What is it? It's the square root function. This is just the square root function, what, shifted 9 units to the right? So it's a half of a parabola that opens upward, yeah? So like, it's just something like this. There you go. Y equals the square root of x minus 9. That's the graph. Yeah? Does that pass the horizontal line test? It sure does, right? If you take a horizontal line and you go through that, you only hit 1 point. At most 1, right? If you're below the x-axis, you hit no points. That's fine. But at most 1 point, so it passes the horizontal line test. Thus, 1, 2, 1 function. Hooray. Keeping with my counterexample, since you asked me about it, what would the graph of y equals x squared look like? The y equals x squared graph is a parabola. And that guy, that fails the 1 to 1. That fails the horizontal line test, you see, because any positive horizontal line like this cuts through 2 points, right? Fails horizontal line test. Therefore, not one-to-one function. It's not a one-to-one function. Now, why do we care about one-to-one functions? Do you guys remember? What's the interesting thing about one-to-one function? I have some problems where I ask you, if it's possible to find the inverse, right? When is it possible? When the function's one-to-one, we can find the inverse. That's right. So let's find the inverse for this one. So how do we do that? We start by writing y equals the square root of x minus 9. There's the formula for the function. And then what do? I solve for x, right? Solving for x will find me f inverse of y. How do I solve for x? Square it. I like it. So we get y squared equals the square root of x minus 9 quantity squared, also known as x minus 9. And one more move, x is equal to y squared plus 9. There you go. That is quote unquote f inverse of y. Now let me rewrite the formula in x, okay? So thus, f inverse of x is equal to what? Well, x squared plus 9, right? Now let's do some thinking. What is the domain of f? I heard a 9 to infinity. That's right. 9 inclusive to infinity, because that's where the square root is non-imaginary, right? Square root of 9 gives me 0. 9 minus 9 is 0. Square root of 0 is 0. Fine. That's also equal to the range, right? That's equal to the range of the inverse function. Remember? That's how it goes. How about the range? What's the domain of the inverse function? Right? That will be equal to the range of the function, right? What's the range of the function here? 0 to infinity, right? Now there's a danger in this kind of example, right? Because if I just box that equation there, right? And I ask you guys, what's the domain for the boxed equation? What would you tell me? In the absence of context, if I just give you the formula x squared plus 9, what's the domain? Is there any x it breaks down for? I mean, no, right? It's just on its lonesome, right? If I just pull out of my hat this equation, g of x is x squared plus 9, what's the domain of g? Well, our custom is say the domain of g is everything, right? But inasmuch as f inverse is the inverse for f, we can't let the domain be everything. It's only the non-negative x. And you can understand this graphically, right? Because if we graph the inverse function, it should be the reflection of that across the line, y equals x. So here's 2 points that are easy to track. You got the point 9, 0. This point up here would be like 10, 1, right? Because if you put in 10, you get the square root of 10 minus 9, which is the square root of 1, which is 1. So 10, 1 is on the graph. And so the inverse, to get the inverse function, we flippity flop. So they're up here, and it's like this. So there you go. That's y equals f inverse of x, which of course is x squared plus 9. But by the way, x is greater than or equal to 0. So it's not the full parabola. It's just half of the parabola that serves as the inverse function for the square root. If instead of giving you plus the square root of x minus 9, I'd given you minus the square root of x minus 9, what would have happened? Oh, any questions before I say more? Nobody? Okay. So here's a thought experiment. If instead I'd given you this, right? Suppose that this was, y equals to g of x was actually minus the square root of x minus 9, right? Then if you go through the same song and dance, that would be, the inverse function would be like this, right? So g inverse of x would be x squared plus 9, where x is less than or equal to 0. That's what would have happened. So that's where the other half of x squared plus 9 is going. It's the inverse function for minus the square root, not the plus square root. It has a purpose, it's just not for our original function. Anyway. So any questions about the mission? We have a quiz, Wednesday, right? Our quiz number 10. What else should I tell you about? So remember, the end of mission 3 is starting to be like review for the final. I should sometime soon tally up the bonus points for the people who have requested CASIS appointments. If you get it done soon, again, if you haven't done it already, if you still do it, I'll probably still take it from you. If you just, send me an email, say, hey, I tried, and this is what happened, blah, 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 whatever. Yeah. I believe the mission is due when you come back. Phew. Yes, it's due the Monday after break. So, yep. The last what? No, I said the last. I'm not sure what you mean. I mean, the last third of mission 3 is based on like an old final exam, I think. I don't think I have that posted, no. Yeah.
So you sent the email you if we did tutoring?
That's right. Yeah, if you requested tutoring, and obviously if you've done it, you've requested it, so that's fine. But yes, I do mean to give everybody who's done that 10 points, like I said. I just haven't gotten around to, adding those up. Let's see here. The other thing that the other section asked me about was, am I going to curve test 2? And the answer is, I don't know. I'm still thinking about it. Okay, probably not. But if I look through and I find out that nobody got a perfect score and there's just no perfect score, and it just escaped my attention because I've been busy, then I will probably adjust the scores, right? But anyway, whether you got the best score or the worst score, you should be looking to replace your test 2 score with your final exam score anyway. And probably the same for test 3. Now, so in terms of mission 3, past a certain point, they're review for final exam problems, is what I was trying to say. So the ones which are most relevant for test 3 are the ones that are not reviewing final exam problems. It's pretty obvious where that happens. Like all of a sudden it starts factoring and long division and that stuff, right? Test 3 is primarily on one-to-one functions, exponentials, logs, all right, and their graphs. And finding the inverse function, the stuff we're just doing. So Wednesday we have a quiz. Wednesday you can still ask me questions about mission 3, anything that's still remaining, all right? You can ask me. And then after break, Monday you turn in the mission. We go over the solution to mission 3. Wednesday is test 3. Wednesday after break, that is, of course. Friday we'll hopefully look at test 3 solution together. And then I think we have one more class day after that to review for the final, right? That's pretty much all that's left. So anyway, I know you guys will be really sad if I tell you that on this Friday we won't meet. Is that okay? That's great, yeah.
Means I can go home.
Yeah. So I'm probably not going to be here Friday because I have a talk I need to help a student with. He's given a talk Saturday. Probably should help him before he gives his talk. anyway. But I think we can wrap up everything by Wednesday. So Friday I will give you some video that you can watch in lieu of live instruction. Sorry I couldn't be here last time, by the way, but you're probably not too upset, I'm guessing. I don't know. But if you have any questions, email me, and like ask next time, it's all good. Thank you, thank you.